Thanks. In this talk, I'll be discussing domain adaptation methods in stylometry. A lot of you have been at previous PETs, so I'm sure that you've seen some of our research in authorship attribution through writing style analysis. Most of this work, however, deals with identifying the authors of an unknown document using other documents of a similar type. So, for example, you may have a Twitter feed, and you're trying to find the author of it, and you have a large suspect set of some sort, and for each of these authors, you have other Twitter feeds that they've written. Unfortunately, this isn't always the case. So again, let's say we have a Twitter feed that we're trying to find the author of, and we have a suspect set, but it's unlikely that we would have a Twitter feed for each of our suspects. And maybe instead we have a blog entry or an email that some of them have written. This work looks at this type of problem and how to deal with it in different solutions. So let's lead with an example. This is an excerpt from a popular blog called The Secret Diary of Steve Jobs. It's very obviously not written by Steve Jobs, but at the time of publication, it was the actual author was unknown. And because of its popularity, a lot of people had compiled lists or had suggested that certain people were the author of this blog. But for all of them, there weren't other blogs that you could use as training data. You might instead, for example, have a Twitter feed. This ended up, Dan Lines was the actual author of this blog, and he published a bunch of tweets that are kind of similar in sound to some of the blog entries from Steve Jobs. Stylometry is based on this assumption that everyone's writing style is unique. So this may be things like regional differences, spelling differences, words that have similar meanings but are different, or different ways to express the same idea. For example, one person may say the fork is to the left of the plate, and another may say the fork is at the plate's left. So this is a privacy conference. How does this all relate to privacy? If writing style is perfectly identifiable, then any anonymous text, online or otherwise, is at risk of being linked to a real-world identity. For example, an anonymous Twitter account or an email from an unknown sender can easily be linked to something similar and someone in the real world. This is a tweet and a blog entry right from our data set. So the goal here is to identify the author of the blog based on a collection of tweets similar to this one. I don't think I have to state that this is kind of a difficult problem given the writing style change across these two examples. This is part of our data set is the blog and tweets, where we have a bunch of blogs that we've connected to tweets by looking for the WordPress string in a person's Twitter account. The second data set that we're using is the Reddit accounts and Twitter accounts, where we link them for people publicly reposting their Twitter handles on Reddit. While other machine learning problems have domain issues, they differ slightly from the problem in stylometry. Let's look at an example. In sentiment classification, you have static classes. So for here, where this is the current pets feed, you can see either live tweets of this current talk or pictures of other people's pets. So in sentiment classification, what we're doing is trying to label the tweets for like good, bad, if you want to know if people are having positive or negative reactions to pets, for example. And maybe you don't have a bunch of labeled tweets as positive or negative, but you can like make your way over to Amazon and buy a TSA simulator toy and look at the reviews, and they're all labeled very nicely with 1 to 5 stars. So you can see if they're positive or negative reviews. In sentiment classification, you might go back to your Twitter feed and maybe label a couple of them manually or something like this, and you have more information that you can use. But in general, the classes don't change. You're always looking for something as good, bad, or maybe even neutral, but in general, it's the same. Stylometry differs, though. So let's go back to the same Twitter feed, and instead, we're trying to link these Twitter handles, some of which may be anonymous, to, let's say, people giving talks today. This is a harder problem, or at least a different problem, because the classes change, because the classes are authors or users themselves, and not just good, bad, or neutral. And we can't go labeling these tweets if we don't know who wrote them. And that's the goal. But like any other machine learning problem, feature selection is an important step. In this work, we use a collection of features that cover different levels of writing style, such as word choice or part of speech tags. Standard stylometric methods, however, using these features that do really well in domain. So in domain in this talk will be the blue bars, and cross domain will be the red bars. So you can see that using those features and using kind of standard stylometric methods you get pretty good results, but as soon as you try to apply those in the cross-domain case, in both of the data sets that we have, you fail pretty miserably. So what can we do about this? Or can we first understand why this is a problem at all? So to do that, we're going to estimate the difference between two domains, D1 and D2, by finding the distance between the average feature vector, which is I, for each author. Essentially here, we're just trying to determine how an author's writing style changes across two domains. And we're going to call this distortion. And the larger the distortion, the farther apart the features are, and therefore the farther apart the writing styles are across domains. So you can see that within a domain, the numbers are fairly small, and across domains, the numbers are huge. So the features are much more distorted across domains than within domains. Also, not surprising, we have better Twitter results than we do Reddit and WordPress results, and the Twitter distortion numbers are smaller than the Reddit and WordPress numbers. So not surprising, but interesting nonetheless. So we saw that features are more distorted across domains here, but is that true of all features or features consistently? Maybe, for example, there's a type of feature that works really well across domains. Function words and part-of-speech tags have been heavily suggested for this. So here we took different types of features and we used only those for the classification. For example, digits or characters or function words. And again, blue is in domain and red is across domain. And we see that nothing really outperforms using all the features together. Especially, for example, function words doesn't do very well across domain as it does for all part-of-speech tags. So features don't change consistently across style within these specific groups, and there's no sort of function, there's no collection of features or a feature type that we found that would work well in this situation. But let's go back to distortion and see if maybe it's not a group of features, but it's a specific group of features, a specific group, not a specific type of features that would change across domain. So here we took the least distorted features and we kept them, and we took the most distorted features and we got rid of them. And we did a dev test set here so that we could make sure that we're not overfitting our data at all. But we see that removing features, even the most distorted features, doesn't improve our accuracy at all. It decreases the accuracy. So while one author may change in one way across domains, another author will change another way, and there seems to be no consistency in how they change. Our first step in fixing this problem was through mixed training. Here's a normal problem setup. We have a group of suspects, and they're all bloggers, and we want to connect them to an unknown Twitter account. First thing we did was throw a whole bunch of other tweets that are not relevant to the other tweeter or Twitter user into the suspect pool, and this attempts to train the classifier a little bit about how tweets are and to highlight the features that are important in Twitter and not in WordPress. And we have a small jump in accuracy here versus the naive method, which was the original one discussed in both of the data sets, but nothing fantastic. So the results are still pretty bad, but how can we change the problem? If we look at this problem as account linking instead of just as an identification, then we have a little more information. First of all, we have more data, and then we also get more information about both of the domains. Let's look at this a different way. If we're looking at, instead of just a Reddit comment, and we instead look at it as a Reddit account, we suddenly have a lot more data to work with on the Reddit side. So let's try to identify the author of this unknown Reddit account, from the suspect set of Twitter accounts. At first, the unknown document is if the first unknown document is assigned to yellow very strongly, and the other ones are assigned to other colors but very weakly, averaging allows us to pick the yellow Twitter account instead of the other ones, even though it wouldn't win by straight voting. Basically, what we do is take the probability values for each of them and multiply them so it favors the higher probabilities and better confidence solutions over the lower confidence solutions, as you can see here. And this method also works, especially well when the errors are uncorrelated, as we showed through the feature analysis in the beginning. Again, we get a small jump in accuracy, especially in the Reddit and Twitter case. And in the WordPress and Twitter case, we get about the same accuracy that we saw through mixed training. But let's go back to account linking. If we're looking at an account linking where we have a whole bunch of tweets and a whole bunch of Reddit accounts that we're trying to link, we can train on all of the Twitter accounts, train on all of the Reddit accounts, and test on one of the Twitter accounts, and then do that for the next and record the probability values as we go. And then we can flip it and do the same the other way, where we train on all of the Twitter accounts and test on each of the Reddit accounts, and again, record the accuracies. What we get from this is for every Twitter account, we get the probability that it was written by each Reddit account, and we get the same the other way. For each Reddit account, we get the probability that it was written by one of the Twitter accounts, the Twitter users. And then we can multiply across and combine the probabilities to get the best match. This is where we see the largest jump in accuracy. And this idea actually comes from another account linking type problem where you're trying to link users in different forums or find multiple accounts within a forum called Doppelganger Finder. And we find that it works really, really well in the cross-domain case as well. So domain adaptation methods are necessary for stylometry. We saw from the beginning that just applying methods blindly to applying methods that work well in domain to cross-domain problem will fail miserably. You need information about both the authors and the domains, and that feature selection isn't the whole story. There's a lot more to it. And we also were able to measure the distortion between the domains and overcome that by adding more information. And kind of the buried lead in this paper is that this also helps really, really well in domain. And we can get fantastic accuracies that are almost perfect in the in-domain case as well through these methods. More generally, what we've learned through this work is you have to be super careful when you're applying machine learning tools to real problems. There's an assumption in machine learning that your training and testing distributions are always going to be the same. In the real world, this is rarely the case, especially in a domain problem where you're changing a lot about the problem, because machine learning isn't just magic, it's math. It's also not about finding the right features, it's about classification tools as well. So with that, if anyone has any questions.